In this video, we'll be discussing alkene stability. And this is important because we're going to be forming alkenes as we discuss the E2 reaction and even the E1 reaction more. And so we're going to see that one alkene, one stereoisomer will form preferentially over the other. Okay, and so because of steric strain, cis isomers are generally less stable than trans isomers. So for example, here we have trans 2-butene versus cis 2-butene. And we can see a space filling model here for the trans versus the cis. So notice the trans has these methyl groups farther apart than the cis, in which they are closer together. So cis 2-butene is going to be less stable and therefore less likely to form. If we consider stability in light of the heats of combustion, you can see that cis 2-butene has a higher heat of combustion than trans 2-butene. And that's because the cis is less stable. So if we could look at that in an energy diagram, we can see we get more energy out from the cis than the trans, even though we get the same products here. These are just isomers of each other, and so you might expect we get the same amount of energy out for burning them. But because we get the same products, right, and we started with basically the same molecular formula, but the trans has less energy than the cis because the cis is less stable. It starts out at a higher energy. And also when comparing the substitution patterns of alkenes, we can see that the more substituted the alkene is, the more stable it's going to be. So these alkyl groups stabilize the alkene by donating electron density into the to the transition state when the alkene is forming, and therefore the tetrasubstituted is more stable than trisubstituted, is more stable than disubstituted, is more stable than monosubstituted. So this one on the left only has one alkyl group and 3 hydrogens. Next, we have 2 hydrogens and 2 alkyl groups. The alkyl groups are outlined in green. Next, we have 1 hydrogen and 3 alkyl groups. And next, we have no hydrogens and 4 alkyl groups. So that's mono, di, tri, and tetra substituted. So let's classify each of these alkenes as mono, di, tri, or tetra substituted. So for A, here's our alkene. This alkene has 1 hydrogen and 1, 2, 3 carbons around it. Okay, we're not talking about the carbons on the double bond. We're talking about what's attached to that. So this is tri-substituted. The next alkene has 2 hydrogens on the right carbon and 2 carbons on the left. So that's di-substituted. The next alkene has 1 hydrogen and 2, well, that's a little trickier, but anyway, this carbon has a carbon and this carbon has a carbon. This is technically tri-substituted. That's a little bit trickier there though, right? The next one has 1 hydrogen and 1, 2, 3 carbons around it, so it's tri-substituted. Okay, so for cycloalkenes, notice that all of these alkenes are cis. Okay, they're only cis, and that's because with less than 7 carbons in a ring, we can't have trans. It just would be too unstable to form. Okay, so unless the ring contains 8 carbons or more, you don't even need to indicate whether that ring is cis or trans, because it really just isn't going to happen. And if you have a bicyclic compound, okay, you can't have a double bond at the bridgehead. It just won't really form unless one of the rings has at least 8 carbons. So the ring with a double bond has to have at least 8 carbons in order to form a bridgehead double bond. So this one on the left is not stable, but the one on the right is actually stable, okay, because it has enough carbons to make that happen. So let's arrange each of these isomeric alkenes in order of stability. Okay, so we're going to consider that for mono, di, tri, and tetra substituted. A let's call these 1, 2, and 3. So for A, we have a tetrasubstituted alkene. So we've got 1, 2, 3, 4 carbons around it. Versus di, this one has 2 hydrogens and 2 carbons. Versus tri, okay. So the most stable is tetra. So it doesn't say which way to arrange them, right? So really we shouldn't use 1, 2, and 3 here, right? So let's not use that. That's probably bad. Let's call them big A, big B, and big C, okay? So A is more stable than C is more stable than B, right? And next we've got, for B, we have di versus tri, okay? Versus, this is also, no, this is mono, okay? So let's call these big A, big B, big C. Okay, so we've got B being greater than A being greater than C, okay? So thanks for watching. I'll see you in the next video.